So in example, or part 2 of section 4.3, we're going to talk about how to find the vertex when it's not in vertex form. So again, vertex form is this a times x minus h quantity squared plus k, where the vertex is this h and this k. Again, when you pull the h out, don't you switch its sign, but because the k is already outside the function, you don't switch its sign. So what we're going to do is in example 2, is we're going to take a look at f of x is equal to 2x squared plus 8x plus 5. And so to find the vertex, we're going to do our old friend completing the square, which we did when we graphed circles, so it should be familiar. We have a few issues, though, when we go do this. So one of the first issues is that we have a coefficient sitting on this. We can't come in and just do halving and squaring. So we are going to factor that 2 out, and I'm only going to factor it out of the first 2 terms because that's where we'll complete the square. So the 5 doesn't impact the completing the square. I can just leave it alone. Notice that that avoids a fraction. Okay, now we'll come in and complete the square. If you remember what you did is you took half of the x term, so half of 4 is 2. We're going to square that, so 2 squared is 4. We're going to add that in. Now, last time when we did this with circles, we added that number to both sides. The problem is that you have an f of x sitting here, you don't have a constant, and you also have this 2 kind of messing things up. So instead, what we do is we add 4 and then immediately subtract the 4. So that way we're not changing the right side of the equation. By adding 4 and minusing 4, we're adding 0, which doesn't change the equation. Okay. Well, next we're going to come in and pull the first 3 terms together. But that means this -4 needs to get moved outside. We're going to factor this in a minute. So this -4 is not going to impact that. But it's got a 2 out in front. So we would essentially distribute the 2 to the -4 and get a -8 and then the +5. Now we can factor. So factors of 4 that add to 4 are 2 and 2. So I have x plus 2 and x plus 2 minus the 3. That's going to give me 2 times x plus 2 quantity squared minus 3. And there it's in vertex form. So we started in standard form. We ended up in vertex form. So what you're going to notice is that our vertex now, using this method, is, again, when you pull it out of the parentheses, switch its sign. So -2, and we go down. So we know that this parabola has been shifted to the left 2, down 3. The 2 out in front tells us that it's concave up. We also know that it's narrow because that 2 is greater than 1. So this method will work, but you can definitely see that fractions might cause an issue. Because if this coefficient doesn't divide by 2, when you factor it out, you're going to have a fraction there that you're going to have to cut in half, and then you're going to have to square, and then you're going to have to factor with a fraction. And in general, that causes some confusion. So there has to be an alternative method. And for you guys, there is. So what we're going to do is we're going to use a formula. So the formula basically says that h, which is the x coordinate of the vertex, x coordinate of the vertex, is basically -b over 2a. So for this particular example, that would be -8 over 2 times 2. Well, that's -8 divided by 4, which sure enough is -2. So notice I'm getting the same number I got over there. K, which is the y coordinate of the vertex. Well, how are we going to find it? Well, same way we're going to find anything. If you know where x is on that equation, you can use x as an input and find the corresponding y value, which is what we'll do. So we're basically going to find f of the answer we just did. So this is saying f of -b over 2a. So that would be f of -2, the answer we just got. So take the answer you just got, plug it back into the function. So that would be 2 times -2 squared plus 8 times -2 plus 5. So -2 squared is a +4 times that 2 is a +8. We'll get -16 and plus 5. So 8 minus 16 is a -8. -8 plus 5, sure enough, is -3. So we got the same answer without having to complete the square at all. So in general, students tend to appreciate this method versus completing the square. So at the top of the next page on the handout is to summarize the different properties that we know. And you can read that. You don't need me to read that to you. So let's walk through and actually graph a parabola. And this time we're going to pay attention to what the width is in terms of intercepts. So that's how we're going to get better pictures. So this is example 4. We want to graph f of x is equal to -x squared plus 6x. So the very first thing they ask us to do is find the vertex and axis of symmetry and determine whether the graph is concave up or concave down. So let's do all that at once. So to get to the vertex, we'll do our negative b over 2a. And again, this is a, this is b. For us, c is 0 in this particular one. b is that 6, all over 2 times negative 1. A is a negative 1. Well, 6 divided by a negative 2 is a negative 3. So our x coordinate, whoops, sorry, the opposite of 6. So gives me a positive. So be very careful with your signs, obviously. So there's the x coordinate of the vertex. We're going to plug that back in and find f of 3. So that would be a negative of 3 squared plus 6 times 3. And again, do the exponent first. So this is 9. This is a negative 9 plus 18, which is going to give me 9. So our vertex is at the point 3, 9. Because I'm going to keep everything over here. So we have it in a minute to be able to graph. So the vertex is the point 3, 9. Okay, the axis of symmetry, which is going to go right through the middle of this, is going to go right through the middle at x equal to 3. So the axis of symmetry comes out to be x equal 3. It is an equation, so make sure you write it as an equation. If you just tell me 3, it's going to get more wrong because 3 is a number. It's not a line. So to make it into a line, we're going to write x equals 3. And then whether or not it's concave up or concave down, it's going to come back to this negative. So that negative out in front tells us it is concave down. So when we go to draw, we know we've got that. Okay, the next thing they want us to do is find the x-intercepts. Well, we'll talk about how to find intercepts, so we can find the intercepts. So part B, the x-intercepts. And we know we find the x-intercepts by setting the function equal to 0. So set equal to 0. That's a negative x squared plus 6x equals 0. I'm going to factor this. I'm going to pull out a negative x, which leaves me with x minus 6 equal to 0. So from the negative x out in front, we'll get a 0. From this one, we'll get an x equal to 6. So our x-intercepts are at 0, 0, and 6, 0. They're also going to ask for the y-intercept. And to get the y-intercept, you're going to replace x with 0. So we're finding f of 0, which in this case is just going to be 0. So the y-intercept we already know is the origin. And again, the reason we already knew that was because we had the x-intercept at the origin. So if you cross the x-axis at the origin, you better cross the y-axis at the origin. So this just backs up this. Okay, at this point, we can go ahead and graph it. So okay. We have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's a vertex. We have an x-intercept at 0, 0, and then another one out here at 6. And hopefully this splits that distance, which it does. And we can see that yes, indeed, it opens down. The axis of symmetry is going right smack through the middle. It is that line x equal to 3. In general, I don't draw that in. This is specific to your textbook, so that's the only reason I'm even talking about it. It does come in handy to graph sometimes, but they also want to know a couple of other things. So the domain, we already know is negative infinity to infinity. Our range is going to be the bottom of the graph to the top. So the bottom of our graph is at negative infinity. The top of our graph is at 9. And we'll put a bracket on it because it's included in that. They also want to know where it's increasing and decreasing. Well, it's increasing on the left side, so from negative infinity all the way to 3. And again, remember these intervals are written with the x coordinates. So from negative infinity to 3, it's going uphill, and it is going downhill from 3 to positive infinity. And then finally, the last one ties into some later information that we need. It wants to know where f of x is greater than 0. So what this is asking is this is y. When is y greater than 0? So where are we above the x-axis? So this is asking when or where is the graph above the x-axis? Well, the graph is above the x-axis between here and here. So the answer to this question is between 0 and 6. That's where the intercepts are coming in handy. They also want to know when the graph is less than 0, y is less than 0. So then this is asking where is graph below x-axis. Well, our picture is below the x-axis on this side and also over on this side. So from negative infinity to 0, and then again from 6 to infinity, the graph is below the x-axis. And there's our first official parabola where we worried about the width.